Welcome back to Basic Biostatistics 2 and to the model number 3, chi-square tests and Fisher tests. In this model, I'm going to teach you how to run chi-square and Fisher tests and SPSS and how to interpret the results. I'll also show you how to make cross tables and how to interpret the percentages in a cross table. We can find cross tables and chi-square tests under Analyze, Descriptive Statistics, and Crosstabs. Clicking in Crosstabs, this opens us the usual table where we have the variables to select on the left side. And on the right side, we can move in the variable, define if it's a row or a column variable. Chi-square and Fisher tests will only run for categorical variables. Thus both variables have to be categorical. Let us assume a research question that we'd like to test whether there's a difference in distribution of the taste of music according to the place of residence. The null hypothesis will be that there's no difference in distribution of the taste of music whether you live in the city or on the countryside. We select the two variables. One of the variables will be the row variable, which we select favorite music of dwarfs, and the place of residency will be the column variable. It doesn't matter if you select the place of residency as column variable or as row variable. The results will be the same. This will give us a cross table. Now we would like to have the statistics of the table, the chi-square or the Fisher tests. So we go to Statistics, and we can see that on the upper left corner we can select chi-square. Selecting chi-square will give us the chi-square test and the Fisher test results. We select it, we click on Continue, and before running the test, I would like you to choose under Cells the percentages of row, column, and total. This will give us the different percentages in the cross table of each cell. We click on Continue and on OK. And we receive three tables in the output file. The first table, as usual, is a case processing summary table. We have 60 valid observations, which is 100%. This means we have no missing observations or missing cases. The second table is the cross table. The cross table is called a 2x2 table in this case because we have two categorical variables and each of them consists of two categories. A categorical variable with two categories is also called a dichotomous variable. How to interpret the different cells? Let's use as an example this cell here. We have 19 dwarfs that live in the city, urban, and listen to Green Day. Or here we have 13 dwarfs that listening to traditional Christmas music and living on the countryside, rural. We have three rows of percentages. We have first of all the percentage within favorite music of dwarfs. This gives us the percentages of the dwarfs that listening to Green Day that live on the urban side and those who live on the rural side. We have 55.9% of the dwarfs that listen to Green Day living in the city. And we have a 44.1% of the dwarfs that listen to Green Day that living on the countryside. The third row gives us the percentage within place of residence. This means that within those who live in the urban side, we have 59.4% that listen to Green Day. And we have a 40.6% that listen to traditional Christmas music. The final percentage is a percent of total, which means that those 19% correspond to 31.7% of all the dwarfs of our study sample, which means of the 60 dwarfs we have. The last table we get in chi-square test are the test results. Chi-square test calculates your Pearson chi-square test. In this case, the value of the test will be 0.205, That corresponds to a p-value of 0.651. It also calculates a Fisher's exact test, which will be for two-sided value 0.795. Always consider two-sided p-values. Never consider one-sided p-values. As this is a 2 by 2 table, chi-square tests are calculated the Pearson and the Fisher's exact test. What you need to know is in which case you have to select the chi-square test, in which case you have to select the Fisher's exact test. Generally, for 2 by 2 tables, the Fisher test is more precise, especially if you have small sample sizes. Furthermore, if we have many cells that have an expected count less than 5, a chi-square test will not be very precise. In that case, we will need to use, for sure, a Fisher's exact test. In that case, we have a Fisher's exact test of 0.795, which is more than 0.05, which means that we accept the null hypothesis and we conclude that there's no statistically significant difference in the distribution of the taste of music according to the place of residency. Or in other words, that the dwarfs who live in the city and those who live in the countryside are equally listening to Green Day as to traditional Christmas music. This is how to interpret cross tables. This is how to run chi-square and Fisher tests. In the end, remember that if you have a 3 by 2 tables or 4 by 3 tables, then SPSS will not give you the result of Fisher's exact test. The Fisher's test is only for 2 by 2 table, which means for two categorical variables that consist of two categories. Once you're familiar with how to do chi-square tests, how to interpret them, and to do cross tables, I invite you to do the quiz and invite you to do the exercises. Good luck and welcome in model number 4.